Hi guys, welcome to the second part in this video series on low-level programs control flow theory. And in this part we are going to take a look at the GOTO statement. And the GOTO statement is usually represented by the jump instruction in the real-world hardware implementations of the processors. So, in order to understand the reason for using GOTO, if you do not have some programming background, I would like to explain this in a simple manner. So you just imagine that you have a playlist with your favorite songs, and the way the playlist is processed by the media player is all the songs are being played one by one. But let's say you are bored of listening your favorite songs in this order and you want to listen to them in some random order. In this case, when the particular song has been played already, the player has to go to some random song in the list, not to this next one after following by the particular one, but just to some random song. And that's exactly the same what happens in the program's control flow at the low level. So say we have the list of instructions, and we don't really want these instructions to be executed sequentially, but instead we want them to be executed in some particular order we have defined before. And in this case, here comes a new term which is called label. So as you can see here, the syntax is like GOTO label. So what this means? Well, the label as well as the instruction is stored in the physical memory. So like here we have the list of the instructions just like in the previous video, but also we have two labels. So the label 1 is located at the memory address of physical address of 0, say, and the label 2 is located at the address of 8. And again, we assume that the instructions are only 1 byte long, as well as to the labels. So the way so what are the labels actually needed for? They are used as the arguments to the jump instruction. So the jump instruction is one of the ways how to manipulate the instruction pointer. I mean, how to manipulate the value that is stored at the instruction pointer. And if you do not know or do not understand what particularly the instruction pointer is, then please watch the previous video which explains it in details. Okay, so say we start the instruction pointer is pointing at the very first location in memory at the address of 0, and the labels are not processed by the processor. Well, maybe I'm wrong, maybe it depends on implementation, but just in order to explain what I want to explain, let's just assume that the labels are not executed. So they like labels, yeah, they are not instructions basically. I'm just afraid to give some disinformation. I've just realized I don't really know whether, well, no, the labels are not instructions, definitely. Okay, forget this. So after the instruction pointer is at label 1, well, nothing happens, for this is just a label, and then the instruction pointer increases, and it now contains the address of the very first instruction to execute. And just like in previous videos, so we are at the we're executing instruction number 1, then instruction number 2. So we were here, then we here, then we here, and all these instructions, which doesn't have any commands on the right side, they do not manipulate the instruction pointer, and they leave the instruction pointer just where it is. And in the case of these instructions, the instruction pointer is simply naturally increased and like kind of goes forwards. Well, but after we are at the instruction 5 here, that in the commands, this is just like a kind of a pseudocode to show that the 5th instruction in this sequence contains the GOTO statement or the jump instruction. So you might have observed this as jump instruction. It depends on the particular assembly implementation. So in this case, the instruction pointer has the instruction pointer's value has been changed, and it says that you have to go to label 2, and basically go to label 2 on the low level means go to the physical address where the label 2 is actually located. And if we see this table, that we see that the label 2 is located at the address of 8. So this means that go to label 2 will bring the instruction pointer to over here to the cell number 8. Let's call this memory cell. Yeah. So all the following instructions has been actually skipped for now, and the reason, just let me say one more thing. So, well, usually, well, at least at x86 processor architecture, I'm not familiar with other architectures like ARM or something, but in the x86 architecture, we don't actually have an ability to adjust the value of the EIP or the instruction pointer register directly using the move instruction, which adjusts the value of most of the registers. So the only way to manipulate the control flow or the instruction pointer register is using this jump instructions and also call instructions, which are the function calls basically. But this is the topic of the next video, so let's get back to our control flow. So we're now at the cell 8 and under the label 2, and here we are going to execute the instruction 1 at the label 2. Well, if we count all the instructions, that it would probably be the instruction number 9, but let's just call it instruction 1, for this is the first instruction at the label 2. So we execute the instruction 1 here, and then we execute the instruction 2 and instruction 3, and the instruction pointer points to the next instruction until we'll reach the instruction number 4. And in this case we see that the instruction 4 again has the GOTO statement, and in this case he wants to go to label 1 plus 6, and this is another pseudocode, assembly pseudocode. You might observe it like so, and well, some assemblers allow you to make such a tricks. And what it means that you have to go to the address of the label 1, which is cell 0, yeah, and then you have to add an offset value of 6. And in this case, so say this is label 1, and then we add 1, 2, 3, 4, 5, and 6. So we are now at the cell 6. After executing the instruction 4, the value at the instruction pointer register is going to be 6. And the instruction to be executed after is actually this one, the 6th instruction of the first label. So we execute the 6th instruction, and then we go to the instruction 7, and then we go to the instruction 8. And the instruction 8 again has the value, has the GOTO statement, and this time we want to go to the location of the physical memory address where the label 2 is located, and then at the offset of 5. So the label 2 is located at 8, at cell 8, and now we want to add 1, 2, 3, 4, 5. So we are now at the instruction 5 of the label 2, or over here. And now we execute the instruction 5 and execute the instruction 6, and then we exit the program. So that's how the GOTO label statement works. And as I was saying before, usually in assembly this is implemented using so-called jump instruction. So the jump stands for you kinda jump from here to here, you jump from here to here, and so on. This is it for this video, guys, and the next video we're going to have a look at the function calls. So how do the function calls work at the low level? See you next video. Bye.